Okay, let's see if we could look at example 2. It says eliminate the parameter from the parametric equation. So, is there a way to eliminate this parameter so we don't have three variables? Okay, notice we just did this one. Okay, so if we're trying to eliminate the parameter, we're trying to get rid of one of the variables. So we're going to try to get rid of t. So we have x equals t cubed, and we have y equals t minus 1. Okay, so we want to solve one equation for t and plug it into the other. This one would be kind of dirty to work with because I'd have to take cube roots, and I don't really like that. So if I work with this one first, I'm going to say t equals y plus 1. Well, when I come over here and I plug it in, it's going to give me x equals y plus 1 cubed. Okay, so now I've eliminated the parameter. The other thing we have to look at, though, is do I have to put any restrictions on what y could be or what x could be? So you have to look at your originals and say, okay, is there anything that is like, so no matter what I put in for t, I could get real out. So I could put in all positives, all negatives for t, and I'm going to get all positive and negative outputs for x. And the same here, I could put in anything in for t, and I'm going to get positive and negative outputs for y. So there's no domain restrictions there. So I don't need to put any restrictions on that. So there we go. There's that example. So notice how here, the same example, well, that's what that would look like, right? That would be y plus 1 quantity cubed, x equals y plus 1 quantity cubed. Yeah, that's what that graph would look like. Now, let's look at this next one. Eliminate the parameter for the parametric equations x equals sine t and y equals 1 minus 2 sine squared t. All right, so we have x equals sine t and y equals 1 minus 2 sine squared t. Interesting. I know that sine t equals 1. Notice here I have, here I have x equals sine t. Here I have sine t quantity squared. So could I do some substitution there? Could I say y equals 1 minus 2, instead of saying sine squared t, I know sine t equals x, so sine squared t would be x squared. Okay, so I think I've eliminated the parameter here, y equals 1 minus 2 sine squared t. But if you think about that, that would be a parabola that goes on and on in both directions forever. But up here, it didn't. So where are those restrictions coming from? Well, this is what we eliminated. So let's think about here. Any input, anything I put in for t is going to give me an output for x between negative 1 and 1, right? No matter what I put in for t, no matter what values I put in for t, I know negative 1 is my lowest output, and I know positive 1 is my highest output. So here, if I'm saying y equals 1 minus 2 x squared, I have to put a restriction on it. So I have to say, well, y equals 1 minus 2x squared. y equals 1 minus 2x squared, where x, there we go, is between negative 1 and 1. Now that will give me that parabola that looks like that. It has a starting and a, well, not really a starting and stopping point, but it doesn't go, it's just going to go back and forth and back and forth. Okay. The last example, it says eliminate the parameter for the parametric equation x equals 3t minus 9 and y equals sine t divided by 3. Okay. If I'm looking at these and I'm trying to eliminate or solve for t in one, I think this one is going to be easier. So I'm going to say x equals 3t minus 9. So if I add 9 to both sides, x plus 9, divide by 3 equals t. Okay, so we have that. Now that I've solved for t here, wherever I see t in this equation, I'm going to plug that in. So I'm going to say y equals sine of x plus 9 over 3 over 3. But we know not to leave a stacked fraction like that. So that's going to be y equals sine of x plus 9 over 9. Okay, because here divided by 3 is the same as multiplying by 1/3. Okay, and now we have to say, okay, so this is the one I manipulated. No matter what I plug in for t, okay, inputs for t, negative infinity to infinity, outputs for x, negative infinity to infinity. So I don't need to put any restraints on this. All right. So that kind of tells you how we're going to deal with parametric equations in this section. One last thing I just kind of want to note real quick is you can use your calculator to do parametric equations. If you just wanted to graph a parametric equation, you would just go to mode. Oops, turn your calculator on. Go to mode and notice that we have function, parametric. So we used polar right in the last chapter. Parametric, if I just went to graph, notice it says x sub 1 of t, y sub 1 of t. So if I wanted to graph this one, I would say just still press this button and notice t comes up. So t cubed and then t minus 1. I don't know what my window's set at. So I'm going to just do zoom standard. Okay, so here's what it looks like. I had to go in and change my window. My T-min was at 0. So I did just negative 10 to 10. You could do whatever you want, just up in your window, change it. And then there we go. There is our graph. So just something to think about. And there we go is 10.7 parametric equations.